Okay, for geometry, lesson 8.2, it is about special right triangles. And these are going to be triangles that either have 45, 45, and 90 as their degrees, or 30, 60, 90. So what you'll notice is they're both still right triangles, but there are some really special things that happen with the side lengths, special ratios that happen in a 45, 45, 90 or a 30, 60, 90 triangle. So here are your notes. Here are the theorems. So in a 45, 45, 90 triangle, what you'll notice is, you know what, actually these are S's, and that's fine because it represents side length, S for side. I actually will usually use X, X, and X root 2. So in every 45, 45, 90 triangle, the two side lengths that make up the right angle are called the legs. Just like in the Pythagorean theorem, these are your two legs, but the legs are the same length. And that is because these, it makes an isosceles triangle because these two are the same length, since we know that these two base angles are both the same length at 45 degrees each. So the side lengths are the same, and the hypotenuse is whatever this x is times the square root of 2. So in a 45, 45, 90, the legs are x and x length, and the hypotenuse is x root 2. So x times the square root of 2. All right, in a 30, 60, 90 triangle, all three are different, obviously, because you've got 90 degrees and then 60 and then 30. So the side lengths are all also going to be different amounts. But what you'll notice is the short leg is just going to be x. The hypotenuse is 2 times x. So whatever the short length is, the hypotenuse is double that. And then whatever the long leg is x times the square root of 3. So x root 3. So in a 30, 60, 90 triangle, the side lengths are x, x root 3, and the hypotenuse is 2x. So knowing that these are the ratios every time in a 30, 60, 90 triangle, or every time in a 45, 45, 90 triangle, you're able to use those special ratios to solve for missing side lengths without having to use the Pythagorean theorem. So find the missing side lengths in this first one. Well, it's a 45, 45, 90 triangle, so that means this is a side length, a leg, and that means this is also a leg. So if this is 9, this is also 9. And the formula is 9, 9, 9 root 2. So the h would represent 9 times the square root of 2. Okay, in this 45, 45, 90 triangle, this is where a little of last year's algebra is going to come in. So we don't know what x is or what x is, but we know that the one that's the hypotenuse is 6. So let's go up and look at this. The hypotenuse is equal to x root 2. And we know that the x root 2 is 6. So how I want you to set this up is I want you to set 6 equal to the ratio x root 2. So it looks like this. 6 equals x times the square root of 2. Okay, and it's been a while, it's been a year since you guys have learned how to simplify, multiply, and divide radicals. So I'm going to work this one out for you to just kind of remind you. So what you would need to do, x is being multiplied by the square root of 2, so you are going to divide by the square root of 2 on both sides. What you do to one side, you do to the other. They will cancel on the right, and it will leave x by itself. And the answer would be 6 divided by root 2, but I hope you remember from last year, you can't have a radical in the denominator of a fraction. This is improper. So what we have to do is we have to take, I'm going to try to find a little space. We have to take 6 root 2, 6 divided by square root of 2, and you have to multiply it by 1. And 1 is anything over itself, so I'm going to take the denominator and put it over itself. So I'm going to multiply by square root of 2 over square root of 2. And again, anything over itself equals 1. So I'm not changing the final answer. I'm just getting it to where I'm rationalizing the denominator so that there's no more radical in the denominator. So when you multiply, you just multiply straight across and squish these two together. So 6 times root 2 would just be 6 root 2. And on the bottom, you can multiply the things that are inside the radical, the radicand, this little symbol. So this would be like the square root of 2 times the square root of 2, which is the square root of 4, which I hope you're thinking that comes out evenly. So remember, you can't have a radical on the denominator on the bottom, but we don't because the square root of 4 is actually 2. So what we have is 6 root 2 over 2, since square root of 4 is 2. And just when you thought you were done, remember, you can simplify the outside. 6 divided by 2. If these simplify, I'm covering up the square root of 2 here. So 6 divided by 2 is 3. So it's actually, if you're not looking at that part, 6 divided by 2 is 3. The answer is actually 3 root 2. So that was a lot of work. I hope you remember, but that is what x equals. So if x equals 3 root 2, then that is, oops, that's here. And that would also be here. And I know it didn't really ask for the one down here. It just asked for up here. Okay, I'll do a few more of those with you too in case you forgot, but hopefully that jogged your memory and at least you're kind of thinking about it. All right, this is a 30, 60, 90 triangle. So let's look at our ratios for that. So the short leg is equal to x. So I have the short leg here that'll just be x. I don't know what that is. I know that the hypotenuse is double my x, and I also don't know what the hypotenuse is, so I don't know that either. But I do know that the long leg is 5. So let's go look at the long leg. The long leg is 5. So that is x root 3 equals 5. So that's how I need to set it up. I need to set it up as x root 3 equals 5. Okay, so I told you guys we'd practice a little bit more with this. Let's practice it right now. So in order to get x by itself, you would need to divide both sides by the square root of 3. Divide by square root of 3. They cancel. You're done, or you think you're done, but you can't have a radical in the denominator. So what we want to do is we want to multiply by 1 in the form of square root of 3 over square root of 3, so that that bottom number, the denominator, pops out as not a radical. So the top, you can just squish it together, 5 times the square root of 3. But the bottom, the square root of 3 times the square root of 3 is the square root of 9. And the square root of 9 comes out evenly as 3. So x equals 5 times the square root of 3 over 3. Okay, so if our long leg is 5, our x, which is going to be our short leg, equals 5 root 3 over 3. So our short leg is 5 root 3 over 3. All right, and then let's look at how to find the long leg. So if we know the short leg, we just double it to find the long leg. So whatever x is, you just take 2 times x. So this is what x is, though. It was 5 root 3 over 3, so I'm just going to multiply it by 2 to get f. So I have 5 root 3 over 3 times 2. And in case you need to know how to do that, anything on the outside of radicals can get multiplied by each other. So this is going to be 5 times 2, which is 10 root 3 over 3. So that's not bad at all. So 10 root 3 over 3 is our hypotenuse. All right, let's look at the bottom of this page. Another 30, 60, 90 triangle. And we don't know anything except the short leg. So let's look at the short leg. The short leg is x. Oh, thank goodness. So x is the short leg, and we know that x is 2. So if we know that x is 2, we know that our hypotenuse is 2 times our x. So 2 times 2 would make this 4. And then our long leg, I'm just going to glance up here again, make sure I know I'm looking at this right. Our long leg is whatever x is, which by the way was 2, times the square root of 3. So you just have to write it like that, 2 times the square root of 3. And that one's done without doing any math. So yay. Okay, this one is also a 30, 60, 90 triangle, and all we know is the hypotenuse. And we know that the hypotenuse, the longest side, is 6. So in a 30, 60, 90 triangle, the hypotenuse is 2 times whatever x is. So if we know that this is 6, then we would know that x must be 3. So our short leg side would be 3. And then our long leg side is whatever x is, which we just solved to be 3, times the square root of 3. So it is just, oh, sorry, it's whatever x is, which we got, 3 root 3, sorry. All right. So let's take a look at our very last one on this page. It is actually a 30, 60, 90 triangle as well, and maybe you couldn't tell that, but this is a 90 degree, this is an altitude, which drops a line down at a 90 degree angle, and since this is a 90 and this is a 60, this one up here must be 30, and since this is a 90 and this is a 60, this one way up here must also be 30. So we're dealing with 2 separate 30, 60, 90 triangles. And if this is bisected, then this means the bottom lengths are cut equally in half. So if the whole length is 12, then that means this side is 6 and this side is also 6. So looking at it that way, we know our short leg of the 30, 60, 90 triangle. We know that the short leg is 6. So let's take a look. Short leg is x, so x is 6. So that means our hypotenuse is double 6, so it would be 12. So the hypotenuse side would be 12. And then I don't think it asked, oh yeah, it did. U is right here, so it wants to know this one too. So we have 6, 12, and then we need the long leg. So the long leg is going to be 6 times the square root of 3 because x was 6. So this, I'm just going to put u down here. 6 times the square root of 3. All right, let's look at the next page, and we'll do a few more of these. I just want to make sure that you guys are really clear on these. I'm actually going to write down, so I don't have to keep flipping my paper back and forth, I'm going to write down the triangles at the top. So we have a 45, 45, 90 triangle. And I will keep these on my whiteboard too, so you guys can refer back to them. So in a 45, 45, 90, the legs are both x, and the hypotenuse is x root 2. Okay, and then in a 30, 60, 90 triangle, the short leg is x, the hypotenuse is 2x, and the long leg is x root 3. All right, I'm just going to use those. Oh, this would obviously be your 60. Okay, so I'm just going to refer back to these as I solve these. So if this is a right angle, then this is also a right angle, and that means this is a 30, 60, 90 triangle here. But on the right, it's a 45, 90. So 45, 45, 90. So this side would be 45. This angle would be 45. So we actually have a couple of different ones to use in this. So I'm going to start on the left, 30, 60, and 90. Just kidding, I don't have any other numbers, so I'm going to have to start on the right. So what I know is that the leg is 5, which also means that this leg is 5, because in a 45, 45, 90 triangle, the legs are the same. So x is 5. I'm going to go ahead and circle that because that's one of our missing lengths. And then the two legs make up part of the hypotenuse. It is whatever the leg is times the square root of 2. So this would be 5 root 2 for y. Now I can come back over here and figure out z and w. So if in my 30, 60, 90 triangle, I know that the long leg is 5, then what I know is that the long leg is 5. So x root 3 equals 5. I'm going to do a little quick cheating because over here we actually did x root 3 equals 5 also already on this side. And so I got it down to where x equals 5 root 3 over 3. So 5 root 3 over 3 is the short leg. So 5 root 3 over 3 is down here. And if you want to rewind the video and see how we did that, you should. But since it's the exact same numbers, I'm just going to shortcut it here. Okay, and then the hypotenuse is double this, and I hope you remember that from the other side. We just multiplied by 2, and you can multiply the 5 times 2, and so that would be 10 root 3 over 3. All right, that one we used a little bit of cheating, but again, go back and watch the earlier part of the video to see how we did this. It's just that it's the exact same. So why not make a little shortcut? All right, so this is an interesting problem. I see a 60-degree angle here, so I need a 90. So what I'm going to do is I am going to cut this right here and make kind of like an altitude. It's totally fine if your line is not perfectly straight. Mine's not either. But I want to drop a 90-degree angle here so that I can have a 60, 90, and now a 30 down here. Okay, and then obviously this is just going to be like a square. I'm not sure if it's an exact square, but I know that this length is the same as this length. I don't know about these two, but I know that from this height to this, it's the same as from here to here. So I'm going to go ahead and write 2 root 3 on this dashed line because it's the same height. So this one is 2 root 3. All right. Next, let's see, if I know that my long leg in a 30, 60, 90 is 2 root 3, the long leg is 2 root 3, this is going to be fun because 2 root 3 equals x root 3. So I'm going to actually come back to that one and do that one here in a little bit because I think there's an easier way that we're going to figure out how to do this in just a minute. So the easier part that I'm thinking of right away is that in a 30, oh, no. You know why? Here we go. This is why I was looking at it wrong. This is 2 root 3, and it already is, the 2 is outside of here, which is our x. So if it's x root 3, and we already have it as 2 root 3, then that means x is 2. So the short leg is 2. That's what makes it a little easier. So the short leg is 2. And the hypotenuse in a 30, 60, 90 triangle, hypotenuse is double whatever x was. So if x is 2, double 2 is going to be 4. So A is 4. Now if from here to here is 2, and they told us originally that this whole length is 5, that means from here to here is 2, and that would mean from here to here must be 3. Because originally this 5 was already there. It told us the whole thing was 5. So if this is 3, then this length down here also has to be 3. All right, I think we solved all of them on that one. Let's move on to this one where once again we have both a 45, 45, 90 triangle and a 30, 60, 90 triangle. All right, so this one, it does not give us any. It gives us the hypotenuse of the 30, 60, 90. So it says 12 is the hypotenuse of the 30, 60, 90. So let's go look. Here's the 30, 60, 90. Here's the hypotenuse. 12 equals 2x. So if 12 equals our 2x, then x must be 6. So that means that our short leg in the 30, 60, 90, which is right here, is 6. All right. So we have 6, we have 12, and now we need the long leg side. And again, the long leg side is 6 because that was our x root 3. So this part down here is 6 root 3, and that's just from here to here. All right, so we're going to have to add it to this part to get our y, our total length. All right, in our 45, 45, 90 triangle, we know one of our legs. We know that this one is 6. So this one must also be 6. And the beautiful thing about a 45, 45, 90 triangle is the legs are the same and the hypotenuse is whatever the legs are times the square root of 2. So 6 times the square root of 2 is x. All right, now to find y, we're just adding these together. You can't add a 6 with a 6 times the square root of 3 because those are not like terms, but we can just go ahead and write them out next to each other. So 6 root 3 plus 6, I don't know why I flip-flopped the order, it doesn't matter. But that's what y would be. 6 root 3 plus 6 for a grand total of whatever that is. Actually, you know what? If you want to, you could go ahead and solve that out and put it in a decimal, but I think it told us, yeah, it actually says leave all answers in simplest radical form. So we're just going to leave it like that. All right, let's do 2 more problems. These are word problems, and then hopefully you will have had enough practice of these 30, 60, 90, and 45, 45, 90 to get you through a few more days of practice. So each side of a rhombus is 14. All right, let's jog your memory. A rhombus is kind of like a square in that they all four have side lengths that are the same. This is a terrible picture of a rhombus, I'm sorry. All four side lengths are the same, but it's different than a square in that they are not 90-degree angles in the corners. But a rhombus has 14, 14, 14, and 14 because what we know about a rhombus is all side lengths are the same. Two sides form 60-degree angles, so these two sides form a 60-degree angle. What we also know about a rhombus, it doesn't really matter, is that the opposite angles would be the same, so this one would also be 60, and these two would be 120. I don't think that matters. Find the area. Okay, we have not talked about area of a rhombus, but I'm going to go ahead and tell you that it is just like a square, base times height. The problem is we have the base. The base is 14. We don't have a height. You can't use the slant height. You have to use an altitude height, which is a 90-degree angle dropped from the top to the bottom. So this is where our 30, 60, 90 triangle is going to come in. We have 60 here and 90, so that makes this little space up here 30. And once we determine what the height is, we can find the area, because then we'll be able to do base times height. Because like I said, we know that the base is 14. We just need to find the height now, which is this part right here. I'm going to put a question mark. We need the height. All right, in a 30, 60, 90 triangle, the only side length we know, we cut this one somewhere, so I would not look at this 14 because this one's cut. But we can look at the 14, which is our hypotenuse. So if you look at a 30, 60, 90 triangle and you look at the hypotenuse, it is 2 times x. So if ours is 14, then that means x must be 7. So x is 7. And what we know about 7 is it would be the short side. So the short side is 7. 7 would be this side. 30 is, I just drew a bad picture, but 30 is across from the side that's the short side. So we're still looking for the long side, I'm sorry to tell you. So the long side is 7 times the square root of 3. 7 root 3. So what we've got for our height is 7 root 3. All right. Okay, so let's go ahead now and put that our height is 7 root 3. Over here, we're trying to find the area. So we've got 14 times 7 root 3. Now, they don't have to be like terms to be multiplied. So you can go ahead and multiply 14 times 7. So 14 times 7 is 98 times the square root of 3. And that would be the area. It says square inches, so inches squared. All right, if we're leaving it in simplest radical form, that's the answer. I see here now that it changed the directions and it said round to the nearest square inch. So actually, if we put that in your calculator, 98 times the square root of 3, I'm going to close my parentheses, is 169, but actually the 7's going to bump it up to about 170 because it says round to the nearest whole square inch. So I'm going to say, or it could be about 170 square inches. Either one of those answers are totally fine. All right, and then let's look at the very last one for today. It is a word problem again, and it tells us that a square has a perimeter. So I'm going to draw my square. What we know about squares is they have right angles and they have the same side lengths. And we know that the perimeter is 48 root 5. So if I just want to find one of those sides, I can divide by 4 because it is a square, which means all sides are the same length. So I'm going to take my 48 root 5 and I'm going to start by dividing by 4. And remember, it's like the root 5 doesn't even count. You're just dividing the 48 by 4. So 48 divided by 4 is 12. And then you've got your root 5 there. So each side length is 12 root 5, 12 root 5. I know this probably doesn't matter because I haven't even read the problem yet. I'm just kind of writing what we know. All right, the problem says, what is the length of the diagonal? So actually, we just need this length right here. And I hope that you know that this is a 90-degree angle, but a square would be evenly cut into, since this is the same side length as this would be an isosceles triangle, which means the base angles are the same, which gives us a 90 and 45, 45 triangle. So a 45, 45, 90 triangle, the rules are this is x, and what we're looking for is x root 2. So if 12 times the square root of 5 equals our x, and we need to put x times the square root of 2, then it's going to be 12 root 5 times root 2. So again, it's because the side length is x. This is x. And our diagonal is x root 2. So I need to put this whole thing in for x times root 2. So it's 12 root 5 times root 2. I hope this is making sense. So quick reminder about radicals. The things that are outside can get multiplied, and this is the only thing that's outside, so it's just going to stay 12. And the things that are inside can get multiplied. So 5 times 2 is going to be root 10. I don't think there's anything that we can pull out of simplest radical form. I think 10 is the smallest already. So this is the answer in simplest radical form, but since this one said round to the nearest whole, whatever, let's go ahead and put that in your calculator too, just to see what that would be. 12 times the square root of 10 is, the 9 would bump that up to 38. So about 38. And it didn't even tell us inches, so I'm just going to say units on this one. So either one of these answers is fine for this.